All right, so chapter 4, review for the cumulative. So a lot of the same stuff we've already done, except now we can finally deal with negatives under the radical. So just like before, we're going to look for a magic number that goes into 80. And that's 16 times 5. 16 is a perfect square. But we have to account for the negative 1. So it's negative 1 times 16 times 5, all square roots. So the square root of 16 is 4. We need to put an I to account for the negative 1. And then the 5 is stuck underneath. Number 2, we need to rationalize this. So we're going to multiply by 5 minus 6i, top and bottom. Okay. On the top, it's a little bit messy. So we're going to FOIL. 4 times 5 is 20. 4 times negative 6i is negative 24i. Inside, 5 times 2i is 10i. And last, negative 12i squared. Now remember, as soon as I write I squared, I'm going to cross it out and put a negative 1, which is going to make that negative 12 become positive 12. And that 12 plus 20 is going to give me 32 on the top. And then combine those, I'm going to get negative 14i. Now I can't forget about the bottom. The bottom I just do first and last. So 5 times 5 is 25. It's always going to be subtract. And I'm going to get 36i squared, which again is negative 1. We're just going to make the negative 36 into positive 36, which gives me 36 plus 25, which is 61. So I have 32 minus 14i all over 61. Now, if any of these numbers could reduce, I would reduce them if possible, but that's my answer. Okay, number 3 is addition. So these parentheses really mean nothing. So I can just add like terms. So 13 minus 8 is 5, and 10i plus 4i is 14i. And that's it. Now, number 4, I got to be careful, make sure I distribute this 3 to both and the negative to both of these. So 3 times 12 is 36. 3 times 6 is 18i. Minus 18 and plus 10i. Now I can join like terms. 36 minus 18 is 18. 18i plus 10i is 28i. All right, so number 5. We need to FOIL, double distribute, whatever. So 4 times 2 is 8. 4 times negative I is negative 4i. 2 times 3i is 6i. And at the end, the tricky part, negative 3i squared. But remember, I squared is really negative 1. We're just going to turn the negative 3 into positive 3, which I'm going to combine with the 8 to get 11. And on the inside, 6i minus 4i is 2i. Number 6, I'm going to rationalize. So again, I can't have the 2 minus 3i on the bottom, so I do the conjugate, 2 plus 3i. The exact same thing, just positive instead of negative. So on the top, I'm going to distribute the 8. 16 plus 24i. Remember, distribute to both. On the bottom, I just have to do first and last. 2 times 2, always minus. 3 times 3, and then I squared, which is really negative 1. We're just going to make the 9 positive, which gives me 13. So 16 plus 24i over 13. And since none of those will reduce, that's my answer. All right, solve by square rooting. So I need to get the square root alone. 3x minus 1 by itself by adding 10. Now, the opposite of squaring is the square root. So that's going to give me 3x minus 1 alone equals the square root of 40. Technically, we're doing plus or minus because we're solving. We're looking for magic numbers that go into 40. That's going to be 4 times 10. So it's going to be 3x minus 1 equals 2 root plus or minus 2 root 10. I'm going to add 1. So 3x equals 1 plus or minus 2 root 10 and divide by 3. So x equals 1 plus or minus 2 root 10 all over 3. Solve using the quadratic formula. So first off, we need to identify a, b, and c. So a is 2, b is negative 3, and c is 6. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 3 right here. B squared a c a. So the opposite of negative 3 is positive 3 plus or minus the square root of negative 3, remember, is 9. When you square a number, it gets positive, so don't put negative 9, most common mistake. Minus 4 times 2, which is 8, times 6, which is 48, all over 4. So x equals 3 plus or minus the square root of 9 minus 48, which is negative 39, but we can deal with that, all over 4. Now, are there any magic numbers that go into 39? Nope, it's 3 times 13, that's it. But we can take care of the negative, which we know how to do now. So x equals 3 plus or minus I square root of 39 all over 4. Final answer. Solve by completing the square. So first thing we do is move the 16 over. Remember, leave a blank here. Now we come below here, we take half of the middle number, which is positive. We're going to square it and do that to both sides. Okay? And now we're going to square root both sides, which leaves us with x plus 2 equals plus or minus the square root of negative 12, which breaks down to negative 1 times 4, our perfect square, times 3. So square root of 4 is 2. Negative 1 comes out as an I. 3. And last thing we do is move the 2 over. Negative 2 plus or minus 2I root 3. And that's it. Number 10 is a guess and check. So the only way to get 5 is 5 times 1. That's easy. Now, 6 can be 6 and 1 or 2 and 3. So we just try numbers. We need two numbers that multiply to give us 6, and it's going to add up to 13 in the middle. So I'm going to try 2 and 3. I do my smiley faces, and that's going to give me 2 and 15. Well, 15 minus 2 is 13, but we need to add up, so that's 17. That doesn't work. So I erase this, I erase this, I erase those. Now I try the 2 here and the 3 here. That gives me 3 and 10. That equals 13. I'm good to go. And since everything's positive, there are my 2 binomials. Now remember, if the 6 was negative 6, then I would have switched it and put the 3 and the 2 in opposite parentheses, and it would have worked out to negative 13 or positive 13, depending on what I needed. All right, graph each of the following. So this is intercept form, because those are my intercepts. I set them both equal to 0 and get negative 1 and positive 3. So negative 1 and positive 3. I'll come back to the other information here in a little bit. This one is in vertex form. Oops. Hold on for a second. Sorry. So remember, this is really x minus negative 5 squared plus 1. So my vertex is negative 5, 1. Right there. And then this is standard form. So one thing I know my y-intercept is here at negative 5. I have that point. All right. All right. Now, let's get to using the calculator to make these easier. So clear it out. I have parentheses x plus 1, parentheses, x minus 3. Now remember, since we know where these are, negative 1 and 3, we also add them together and divide by 2 to find the vertex. So 3 minus 1 is 2, divided by 2 is 1. So we know that the vertex is going to be at x equals 1. And the calculator tells us that 1, negative 4. Which again, once we know 1, we can put a 1 here and a 1 here, crunch the numbers, and it would give us negative 4. But let the calculator help you. Okay? The axis of symmetry is at x equals 1. Don't forget the x. Now, since these are all parabolas, the domain on all of these is going to be negative infinity to positive infinity because they're going left and right forever. Okay? The range we'll get to. So back to the calculator. All right? We just put some points here. So we get no negative 1, negative 4. I'm sorry, 1, negative 4. And we look for 0, negative 3, and 2, negative 3. And that's enough. We have our general idea what it's doing. Okay? Now remember, this number goes down here to the range. It's bottoming out at negative 4 and going up towards positive infinity. And we use a bracket to include the negative 4. Right? Next one. Y equals, cleared out. We have the negative, parentheses, x plus 5, parentheses, squared, plus 1. Okay? Now remember, we already know that the vertex is at negative 5, 1, which gives our axis of symmetry at x equals negative 5. Right? And since it's flipped upside down with that negative, we know it's going towards negative infinity. So it tops out at negative 1. So it's going towards negative infinity and tops out at -1 with a bracket. And now we just need some points to put on there. So there's our vertex at -5, 1. So -4, 0, and -3, -3. -4, 0, -3, -3. And then we just do mirror image at 6, 0, and -7, -3. And if you want to be more exact, you can put more dots on there. All right, last one here, number 13. Clear it out. -2 x squared plus 8x minus 5. Graph. Okay. Now, mathematically, how do we find the vertex? It's opposite of b over 2a. So opposite of b over 2a. So -8 divided by -4 is 2. So we know it's going to be a 2 comma something. Now we can plug the 2 in or just let the calculator do the lifting for us. So the vertex is at 2, 3. Okay. And we get 2, 3. We get 1, 1. And 0, -5, which we already had. So now we just do the mirror image. If it's 1, 1, then it's going to be 3, 1, and 4, -5. And now we have our 5 dots. Again, we'll make it more accurate, but that's enough. So my vertex, again, was at 2, 3. Axis of symmetry is x equals 2. And it's topping out at 3. So again, it's going towards negative infinity, topping out at, not 2, topping out at 3. Let's just clean that up a bit. And it's got a bracket because it hits there. All right? Now number 14, the classic something going up in the air and coming down. All right, write an equation for it at 80 feet per second. That's the velocity. And starting at 30 feet, that's the height. So we just say h of t, height as a function of time, is -16 t squared plus 80 t plus 30. We go to our calculator and put that in. Clear it out. -16x squared plus 80x plus 30. And we graph it, see what it's going to look like. Hard to see there. So we go to our table. And it says, where would it be in 1 second? It says right there, 94 feet. How many seconds does it take to reach its highest point? Well, again, what's its highest point? Well, the highest point is opposite of b over 2a. So that's -80 divided by -32, which is 2.5 seconds. Now, remember, the calculator does not show us 2.5. It shows us 2 and 3, which are both 126 feet. So, therefore, we need to find 2.5. On your calculator, you can just change this down here to 0.5. And then when you go back to your calculator, it's changing by 0.5s. So 2.5 is 130 feet. Okay. Now let's grab, okay, I'm not going to bounce back and forth. I have it on my calculator in my hand, but we knew it started at 30 feet. Okay, so that's right here, 30 feet. All right, we know that it tops out at 130 feet at 2.5 seconds. So 2.5 seconds is right here. So 130 feet, there's 120, there's 140, so that's 130 right there. Now, at 2 seconds, it was at 126. So pretty close to that. And at 3 seconds, it's at 126. At 1 second, it's at 94 feet. We already found that. So at 1 second, 80, 90, about halfway. And at 4 seconds, it's also at 94 feet. So about the same there. So we can see what it's doing. Well, that's a horrible one. Now, where is it going to hit 0? Well, if you look at the calculator, between 5 and 6 seconds, technically between 5 and 5.5 seconds. So, it's going to hit 0 somewhere around there, between 5 and 5.5 seconds. So, approximately, okay, now if you said 5 to 6 seconds because you didn't do halves, that's fine, but you kind of need to do halves to get this answer here and here. All right? Now, how do we find get the full points for this? It says round to the nearest decimal 2 places, so we have to do the quadratic equation. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what was our a, b, and c? A was negative 16, b was 80, and c was 30. So opposite of b squared minus 4ac, and that's a. We have some big numbers here, but we have a calculator. So negative 80 plus or minus the square root of 80 squared, which is just 8 times 8 with 2 zeros. So 6,400. Now careful, this is minus times a minus. So 4 times 16 times 30. Because minus times minus makes it positive. So that's plus 1920 all over negative 32. So 6,400 plus 1920 is 8320. So negative 80 plus or minus the square root of 8320 all over negative 32. The square root of 8320 is plus or minus 91.21. It's 214, the 4 rounds down, all over negative 32. So now you just do the number crunching. Negative 80 plus 91.21 equals 11.21 divided by negative 32 is negative 0.35 seconds. Well, that's out because we can't have a negative time. So we do negative 80 minus 91.21, which is negative 171.21, divided by negative 32, and that's 5.35 seconds, which we said was between 5 and 5.5. So there's our answer. And that's it.